You know, every time you hop in your car, you're literally surrounded by this amazing technology that you've probably never even thought about. It's kind of like this hidden force, a secret skeleton that's shaping your entire drive. So in this explainer, we're going to pull back the curtain and take a look.
So, let me ask you a question. What on earth could possibly connect the roaring heart of a gasoline engine to the quiet, futuristic battery pack in an electric car? I mean, on the surface, they're polar opposites, right? They seem like they're from completely different planets. Well, the answer is actually pretty simple, but it's incredibly powerful. It's aluminum die casting. Yep, this one manufacturing process is the common thread that ties the old-school world of combustion engines to the brand-new revolution in electric vehicles. And to really wrap our heads around its huge impact, we've got to start where it all began, deep, deep inside the traditional car engine. So what is this stuff anyway? Well, I want you to imagine a super high-tech, high-pressure jello mold, but you're making it out of metal. That's the gist of it. You take molten aluminum and you blast it into a super precise steel mold, they call it a die, and you can create these incredibly complex parts with amazing speed and accuracy. And for decades, this process has been the absolute go-to. I mean, we're talking about the very guts of a traditional car, the engine blocks, the massive transmission cases that hold all your gears, cylinder heads, even the oil pans. All these vital, complicated parts are made this way because it's strong, it's precise, and honestly, it's just the most efficient way to do it. But the story doesn't stop inside the engine. Not even close. The technology evolved, and it moved from making these smaller components to creating the very bones of the car itself, building something way, way bigger. And this is where we see a huge leap forward. See, the old way of building a car's frame involved taking dozens, sometimes hundreds, of little stamped steel pieces and welding and bolting them all together. It was complex, it took a lot of work, and it was heavy. But now, with something called Megacasting, car makers can create one enormous single aluminum part that replaces all those little pieces. It slashes weight and radically simplifies how a car is put together. So what parts of the car's skeleton are we talking about? Well, critical things like the shock towers that your suspension bolts onto, door frames, key structural body nodes, and the subframe elements that hold up the whole engine and drivetrain. It is a fundamental change in how cars are built from the ground up. Okay, so we've gone from the past to the present, and now we've got to talk about the future, because this exact same technology is now right at the center of the EV revolution. And this is where it gets really, really cool. Die casting is essential for the two most important systems in any EV. You've got the battery, where it creates these super strong protective housings, and the cooling plates that are just vital for managing temperature. And then you have the electric drive unit, where it forms the motor housings, inverter cases, and gearboxes. It's everywhere. So, why should you care about this as a driver? Well, because these die-cast parts are absolutely crucial for an EV's performance and its safety. They manage the intense heat coming off the battery, they provide the structural strength to protect it in a crash, and they even shield all the sensitive electronics from interference. It all adds up to better performance, more range, and a much safer car.
Okay, so we've seen the what and the why, but how does this magic trick actually happen? Let's take a quick peek behind the curtain at the unbelievable forces at work here.
First off, there's the pressure. It's just insane. The molten aluminum is injected at up to 1,500 bar. To give you some perspective, that's like the crushing pressure you'd feel at the bottom of the deep ocean. That's what it takes to make sure every last nook and cranny of the mold is filled perfectly. And then there's the heat. Whoa! We are talking temperatures hitting 710 degrees Celsius. That's over 1,300 degrees Fahrenheit. It's hot enough to turn solid aluminum into a free-flowing liquid ready to be shaped. And maybe the most mind-blowing part of all is the speed. The entire cycle, from liquid metal to a solid, complex, almost finished car part, can take as little as 30 seconds. That incredible efficiency is what makes mass-producing modern cars even possible.
But listen, speed is nothing without precision, and these parts are put under a microscope. They get X-rayed to find any hidden flaws inside, measured with incredible accuracy, and checked for a perfect surface. I mean, these are critical safety parts. They have to be absolutely perfect.
So, with that kind of speed and that kind of precision, where can this technology possibly go from here? Well, the future is already being cast, as they say. There are really three big forces pushing everything forward. The biggest driver, making up about 40%, is just pure weight reduction, making cars lighter so they're more efficient and have better range. After that, it's all about making the manufacturing process itself smarter and better. And finally, there's a big, growing focus on sustainability, using more recycled materials and less energy.
And this innovation is really happening on three main fronts. First, you've got smarter processes, like something called vacuum casting, which actually sucks all the air out of the mold to prevent tiny defects and make stronger parts. Second, there's smarter design, using these advanced computer simulations to perfect a part before a single drop of metal is ever poured. And finally, we're building smarter factories with way more automation and integration.
At the end of the day, this isn't some old, static technology. It's constantly changing, constantly getting better. From old-school engine blocks to these new Megacast EV platforms, it has been, and it's going to continue to be, absolutely vital in building the cars of tomorrow.
Which kind of leaves us with this one fascinating question to think about. We've already seen the entire front and rear sections of a car's structure made from a single piece of aluminum. As this technology gets even more advanced, what's next? The whole door frame? A roof structure? I mean, could we one day see an entire car chassis pop out of a machine in a single shot? The possibilities are just incredible to think about.